Hello, welcome to ZIM Capture. I'm inventor Dan Zen. And ZIM at zimjs.com is an open source framework to make interactive media on the HTML canvas using JavaScript and Create.js. In this capture, we're going to take a look at how to bring physics into ZIM, and in particular Box2D. So let's take a look at some examples. We'll go to the site at zimjs.com and scroll down. Oh yeah, this is an example right here. So if I go push, oh, look at that explosion. Isn't that neat? So that was physics to cause that explosion. And if we scroll down a little bit more into the ZIM bits, now pay attention to how we're doing. This is down in the ZIM bits area, and there's the soup and a basic physics. So let's click the basic physics one. Oh yeah. So what we've got are Box2D objects that are invisible, and then we're mapping on top of that. That's a rectangle, so a ZIM rectangle and a couple of ZIM circles and stuff, and we map those on top. All right, so that's, and this bar is not moving, that's fixed. It is not dynamic. These ones are dynamic, and we've set the drag as well. We also are not falling off the screen for some reason, and we're going to see why that's the case as well. So if we go back and choose the soup, here is the soup, and this is obviously a more advanced version with buoyancy, and we can click and add a whole bunch of stuff, or even hold down a key and just, there we go. Ah, that's a lovely soup. Okay, so isn't that fun? Wow. So these are images then that have been mapped onto the Box2D. Okay, so let's close this down and take a look at some code. Here we are we're going to do something similar to that basic physics example. To do that, we need to bring in the physics library. So you can go to those basic physics examples and find this code right here. We're bringing in the Box2D code. We've stored that in our own CloudFront here so that that's fast for everybody, and you'll always have it. As long as you've got ZIM, you'll have Box2D. And then we've got a physics helper class that we've made to help us with Box2D. All right, let's scroll on down. So an overview. In general, we set up the virtual Box2D shapes, and then Box2D will calculate forces and positions and rotations and collisions. We can see these if we set the debug on. And then we can map our own ZIM and Create.js assets onto the Box2D ones. And you're not supposed to directly influence the positions of those. You're supposed to let the forces in Box2D handle that. All right, so let's see what that looks like. We can make a new physics object that will help us. This is the helper class, so var physics is equal to new zim.physics. Like so, and in that we pass the frame. So this is a reference to the ZIM frame here, not a reference to the stage, but a reference to the frame. And then we can also pass in some boundaries, but let's try without the boundaries, and then finally you can pass in the gravity. Now, if you're wondering where we can see what we can pass in here, it's not part of the traditional ZIM docs. So what we need to do is come on up here to the physics JavaScript helper file itself, and then we'll pop this into a browser. So at the moment we don't see anything on the stage there, and we paste that and we should, yeah, here we are. Okay, so physics is an add-on ZIM module to help with Box2D. All right, now because it can get pretty tricky, let's just give you an idea. For instance, can we change the wrap on this? I don't think we can. I'll just open that up. Let me give you an idea of what it's like to make a rectangle. So here's, by the way, some documentation on that. We can make a rectangle, a circle, a triangle. Here's how you add, there's physics, frame, border, and gravity, a little bit about that, and what the how to add the borders. We'll do that. Okay, and there's to set the debug going, to drag something, that's what you do, and to map something. So we're going to be doing all that in this ZIM Capture. Down below there's some properties that we can get back from Box2D as well, and you're welcome to use any of the Box2D classes in conjunction to what we're doing here. But as you can see, they're a little bit tricky looking, and all of these things, most of those things we have to do to even make a rectangle. So if we scroll down here, there's, sorry for the wrap on this, there's make a rectangle. And what the make rectangle does is it just piggybacks on make shape. So it passes rectangle specific things into make shape. Make circles passes circle specific things into make shape, and make triangle passes triangle specific things into make shape. So here's the function make shape, and these are the types of things that we would have had to done if we have done if we didn't have the physics helper. We would have made a new definition, which is a B2B body definition. If it were dynamic, we would set that to be a B2B or B2 underscore dynamic body versus a static body. That's the type of the definition. We'd add some damping if we needed to. We would make a body by creating a body and passing in that definition. It's a little bit awkward. This is a function, it's not a method. Or sorry, it is a method, regardless, but it's not a class. It's a method. And yet Box2D, I think they're European or something, they capitalize their methods, which is annoying. So just watch out for that. And there's like shape.set as box. That's a method, and yet they're capitalizing it. Anyway, there we are creating a body. If it's a rectangle, we have to make a polygon shape and set it up. And then we set as the box, like set as box, that shape. And then that's what we would do for a triangle and for a circle. Then we make a new fixture. And we might have to do something to that fixture. Then we set the fixture shape to the shape. We can then set the density and friction and restitution of the fixture. Then on the body, we run the method create fixture and add the fixture to the body. And then we can position it. If we want to position it, we have to use B2B vectors and stuff like that with a set position method with a capital S. Okay, it's like, okay, blah, blah, blah. So let's close that down and let's use the ZIM helper class instead. So in other words, to make a rectangle in traditional Box2D is at least 8 lines of relatively complex looking code, all in the name of flexibility so that you could, I don't know, reuse certain little parts of it and stuff like that. It's just like, oh God. Anyway, what we can do instead is we can say var bar body, like that, is equal to a physics dot make rectangle, like so, and we give it a width and a height of, say, 20 or something like that. We can pass in other parameters there too, as you may remember. We'll take a look at least one of those a little bit later. But there we've got a body. So physics dot make rectangle on that. And now we won't see it. Would you like to see it? Would you like to see nothing? So there we have it. It's not there. Now there's no adding it to the stage. We do have to, and eventually we'll make our own ZIM and Create.js shapes and stuff, and we'll add them to the stage, and then we'll map them to this. So if we want to see the debug rendition of it, a debug rendition is sort of what Box2D comes with. And if you take a look at Box2D examples, many of them are just the debug renditions, because the idea is you're supposed to map your own assets on top of those. Then we can do it like this, physics.debug, like so. And that should mean that we see that bar. It may fall from the top and go to the bottom. I'm not sure where we're going to position that thing. There it is. It just kind of lumped itself there. Don't know exactly why, but there it is, sort of lumped. Oh, the debug, we've got to watch that. The debug may need to be resized when we resize the stage. So that looks like this. It looks like frame dot on resize. Oh, that's just a string there. Call this function. Boop, doop, doop. And in here we can say I can spell it. Did I spell it? I think I'm missing something. Physics dot, maybe we should have called it just P, physics dot update debug. I believe that's what it's called. Okay, so let's save this up and run it and see. Are we getting any errors on this thing? F12. No, we're good. So there's a bar. I'm not sure why it's gotten itself snagged on that corner like that and hasn't just fallen down. Let's see if I've the debugging of the, just pop on back to the debugger. Is there something going on with the debug? Update debug, not sure. Let's position it and see if it has better luck. So we'll go bar body dot x is equal to, say, 300, and bar body dot y is equal to 300 as well. I think we've got gravity in there. Oh, should be fine, but okay, let's start her on the stage proper. Oh, there it goes. Okay, so it must have just been snagged on the edge, which is kind of funny because it shouldn't have any edges, but oh, it does. Oh, I see. Right, of course, that makes sense. By default, we've given it edges. I can see them. You see this green that's around the outside? It's showing us that there's actually something there. Maybe we can see that if we oh, but we did the resize already. So let's actually turn off the resizing. So I will not update the debug screen. Refresh. And there it falls, and yes, there they are. So thin little borders have automatically been placed around the frame for us. Nice, huh? And so what was happening before we positioned it? So no positioning there, and a refresh here, is the bar was actually kind of, well, I guess we still can't see it. It's kind of snagged on that. We placed it inside. Ah, yes, that's the other thing. When we place anything in Box2D, it's center registration. So that bar that we made, the center is placed right inside one of our very thin borders and therefore has not fallen. Now note that if we don't refresh that debug, do you see what's happened? It sets it up the very first time, but not ever after. Not ever after. So hence the updating of that. Whenever we resize the frame, we're going to update our debug so that it's in the proper position. Let's take a look at that again. Although this is quite annoying to have that bar stuck up in there. Great, now it's refreshing with the stage as it moves. Okay, so what do we do about that bar? Well, as mentioned, I guess we can position it in place like so. And then it just falls and it hits the bottom. Now note, as it's falling, you see that it's pink, but then when it stops, it's brown. The debug will show you when forces are acting on it versus when it's stationary. So at the moment it's stationary, and now it's being acted on, but now it's stationary. Okay, so let's turn that bar so it just stays where it is, and we do not want a dynamic body. So a dynamic body is true by default, and the next parameter here is we just set that to false. False. It's very fancy, fancy spelling of the word false. Okay, so there it is, false, and we refresh here, and look at that. It's now stuck there. So funny, it is green, but it is stuck there anyway. I guess some force keeping it there is placed on it. All right, let's move it down a little bit, shall we? How about a bars Y 500? We'll put it down a little bit. Not that it matters. In that one example, you saw that I made that slanty, so we could do that too. But let's just have it capture something at the moment. And what shall it capture? Shall we just make a copy of this? Should we capture? We've seen a rectangle. How about a circle? What does a circle look like? I would imagine that we've just got one thing here, and that might be its radius. And so we'll make a circle with a radius of 50. We'll put it at 300, 300, like so. And that won't be a bar body, but rather a ball body. Here's a ball body. Ball body, ball body, ball body. So we save that up. And, oh, okay, we'll start off with it false, just kind of hanging there. Whoa, just kind of hanging there. But then we'll quickly remove that, and therefore it should fall. And it does. Nice, huh? Bomp. That's it. Not even a thought of rolling. Oh, we know that that probably wouldn't happen. And note that the circle is showing a little line on it, and that allows us to see when the circle does roll. Shall we make the circle roll? Well, we could rotate this a bit. Bar body dot rotation equals 20 maybe, something like that. And let's see. Yeah, there she goes. I wonder, I don't know how we get rid of the, we'd have to look at the documentation. One of these things, how to get rid of, sorry, the borders around it. I just wanted to show you what it looks like when it just falls right off the screen, which is sometimes fun and also sometimes necessary. Yeah, so how would we do that? Would we pass in, oh, let me just try passing in false. I'm not sure if that would do it. Ah, there it goes. Okay, so no border around it. So that's been set as false. Let's show that again. And off it goes. So if you, in your physics, you want things to come in from the top or in from the sides or anything like that, then you won't want to have borders around them, because then those borders, not only do they stop things going out, but they also stop things coming in. And as we saw when we placed our rectangle, our bar, you know, stuck it up there. Okay, well, let's bring back those borders so we won't pass in false. The other thing is gravity, so I suppose let's put in false for now, and then also let's put in -9, is it? I think something like that, and refresh. Whoa, did you see that? Whoa, sorry, like it's like we're upside down, or that's floating away or something like that. So you can adjust that in a variety of different ways as well. Like you can set some properties of the body so that it floats up instead. All right, so there's some bodies. So far, so good. What I'd like to do now is let's just turn on the drag of those. And so that is physics.drag. Now, I had to go to a fair bit of trouble to make that. Is it worth it? Okay, believe me, if you go in and take a look at how you would set up dragging in Box2D, and you'll see that that's not terribly easy. Now, I actually didn't really do much of the calculations of how to drag it. They had already been done for me, but I did wrap it all up into a drag and applied a few other things so that it would work at various events. But there you go. Now, when we're dragging, it's not really a drag. What we're doing is we're applying a force to it, and you can see that. You see that little line? If I do it fast, you see a line, and watch this as I pull it through. That line is a joint. So we're joining, it's a mouse joint from my cursor to that thing that I picked up. And I made that mouse joint activate on where we picked up that circle. So yeah, there were a few things we had to do to make that work properly. But that's kind of cool, huh? Now you can drag certain things and not other things. That one's fixed, so we can't drag it. But this will just drag them all, although if you take a look at the documentation, there is a way to specify, well, which ones of these do we want to drag? Okay, so that is the dragging. Next, for physics, is we want to map our own things onto these. So that's pretty good so far. Let's leave it at that in terms of the physics of things. What we want to show you now is how to map our own shapes onto it. And if you want to know anything more about physics, you'll have to look into Box2D or take a look at some of those the examples that I showed you. The explosion one is good to see for forces, like how to add forces to make things move. That's what we were doing there. The soup is good for things like buoyancy, and a few other tricky things are in soup. So have a look at the soup as well for more advanced physics. And of course, there's online examples of Box2D, which has been around for ages. All right, but let's do some mapping. And mapping was all sort of created through ZIM and by ZIM to handle this. Let's take a look. What we do is we make the ZIM shapes, of course. So we'll make var bar is equal to a new ZIM dot rectangle. like so, and we want it the same width and height. So probably what would have been better is if we set these up as variables. Var bar width is equal to 500, like so. Var bar height h is equal to 20. Like so. Well, we have to do this with the position as well. Let me just think. The position. Boop, 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 boop. I think we can handle it. I think the mapping will handle that automatically. That's kind of what the mapping does. So bar width and bar height. Down to the rectangle, bar width, bar height. And we can give that a color as well. Frame dot. What color haven't we used in a while? Let's try orange. Okay. Now that can be also an image that you load in with load assets. It can be, other stuff. We can make this animate. It could be a sprite sheet, all that kind of stuff. So there's our bar, and we want to add that to the stage. Now, we should center reg this as well. If we want to map, this is important, if we want to map, we need to center reg the things that we're mapping. So dot center reg on the stage. Now, that centers it on the stage, but it also centers the registration, and it is adding it to the stage. So it really doesn't matter if we center it on the stage or not, because as soon as we map it, it's going to pick that up. But for now, let's just kind of see without the mapping, there she be. So no mapping, there's our bar, and you can see that it appears that it's just getting ignored. So there's that, and also we want to do the same thing with a circle. So, I mean, we could do one at a time, but we'll just do it this way. Circle, oh, we'll call that a ball. Ball, I think, yeah, we'd call it a ball up here. It doesn't exactly matter that these match, but we like to keep it consistent. So there's the ball, and we would like a ball radius probably here. Var ball, can do it. Ball r is equal to 50. And then we take the ball r from there and place it in there like so, and place it here and take it down here. And that becomes a circle. So var ball is a new ZIM circle. We'll make this one green, 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 green. And we'll center that one on the stage too. And so now we've got both the ball ready to be mapped and the bar ready to be mapped. And when we map them, it'll just plop them into the same place. Okay, so that looks like we use, on the physics object that we've made, we've got a way to map them as well. So that would be using the add map. So it looks like this. Physics dot add map. And then we say the Box2D one, which was bar body, comma, bar, like so. So can't really be too much easier than that, can it? There we go, and that's nice. In the past, I've been building with Box2D for a long time, back in Flash even, and stuff like that. And in the past, if we wanted to do what we've got here, this stuff right here, if we wanted to do that, we would be talking close, certainly around 100 lines of code, maybe more. And it's 100 lines of yucky looking code. Yucky, yucky, yucky. As a matter of fact, if you included the drag in there, we're talking more like 400 lines of code, 300 maybe. Okay, so physics dot, oh, where'd we get to? We're mapping. Well, let's see if this works. But it's not the, we don't want the bar body, we want the ball body, and we want to map the ball to that. So we save that up and check it out here, refresh. Oh, isn't that cool? And I'm picking it up. And so that's the ball on top. It looks a bit ugly because the debug mode, we've had that so that it goes on top of our stuff so that we can still see the debug mode. In other words, we just don't want to debug at the moment. If we we'll just scramble that up, that won't debug. Yeah, we don't want to debug at the moment. So we'll turn the debug off. And now we've got a nice orange ball and so forth. Now, just a bit about those, the rectangle, or the borders of that. Let's adjust it. You see how this is going down into our footer here? Let's adjust it so that those borders don't go down into the footer. Okay, so that's up here. We need to know how to pass in, comma, what would be called, say, the borders. Borders like there. Border probably is fine. So that looks like this. Var border is equal to, it's, as far as I can remember, let's see, I think it's an object, and in that object we specify the x, the y, the width, and the height. Okay, so let's take a look. The x would be 0. The y would also be 0, so that's the top left corner. And then we say how wide we want it to be. The width would probably be the stage width, like that. And then the height is what's going to change. So if we made a height, let's just check this out, height of the stage height, then, and that is the border, and we pass the border in. Let's refresh here and see if that border is showing up for us. It does. Well, it seems to be working how it had before. Oh, we don't have the debug in, so on the debug we'd see it even more. We'd see a little bit of green or whatever was on the side there. Yeah, there it is, green on the side. Let's bring that up though. Bring it up. Blech, blech, blech. Where was it? Stage height minus 200. I don't know how much we need. And we refresh. Well, we don't need that much. But there it is running along the border, as you can see there. So maybe 100 would have done it. Just barely. And let's turn the debug back off like that. And a refresh. And there we are with the final. Nice, huh? Do you like that? I do love it. I think that's pretty amazing. That is physics here at a ZIM Capture. I am inventor Dan Zen, zimjs.com. Have a great day. We'll be taking a look at some 3D next. How do we get 3D into ZIM? Ciao.